Hello, this is Yannis from Any Repair. Today we'll go through a notebook, a MacBook Pro a2141 that came to our lab dead. That was a tricky repair, so let's go and see how we'll deal with this damage. That is the board, it's on our desk, we are tenderly holding it because we want to fix it. We're trying to plug the charger and have a better focus on the camera in order for you to see better. And now we will plug the charger and nothing special will happen. It stays in 5 volts. Let's go see the other port. Nothing special, 5 volts only. It's not negotiating the 20 volts as it should. Let's go and see if we are having a PP bus. We are not having anything. No, we're not having anything. So let's go and investigate this one. We will go on the microscope and focus on the U7000, which is the charging IC. And we will check around this IC if we are having the VCC mainly. The 5 volts are coming there. No VCC for us. The capacitor is not receiving any power. So we'll go and see if we have a short there, which is present. Yes, the ground is ground, but the other pin should be high, and it's not high. It's very low. We have low values in the scale of ohm on this power supply. So we are assuming that either the capacitor is blown or the charging IC is blown. And we will see now on the board view that we should have something like kilo ohms, because this is an LDO. So we will remove the charging IC and test if the short is removed too, or we are still having the short. We're using a tweezer and our hot air. We are very careful not to blow something away with our hot air gun. Now we will remove the bolts, the bridges from the pads and check again. We are not having any short now, so the shorted component was the charging IC, the U7000. So we're cleaning up the remaining solder, trying not to rip any pads. I think I have done something in the middle, but this is a no connect pin. You can see if I clean up better. You can see that there in the middle something is missing there, but it's a no connect. So we are not caring about no connect components or no connect pads. We will have a U7000 from a donor board, which we are going to reball. This is the pad that it's no connect. I'm not assuming. I always trust and study the board view. Now, the new charging IC, the charging IC from my donor board is going to be reballed. We are very careful not for scraping any UV mask any mask from the IC, because it will be very difficult to recover the chip and the pads. So we're not very thorough on cleaning the pads, because the reballing will fix all the uneven balls. We're using a universal stencil, as you can see, which fits the IC. And now we will apply some paste and heat the IC, and the balls are greatly generated. Now we will remove the IC. We are still having the balls on the IC. We will remove any excess solder, any excess balls that have created. We will reflow, and I think we're ready to solder the new IC in place. We will add some flux. Flux is our friend. We will align the IC, and after a good alignment, we will try and solder the IC on our board. The alignment is not so easy right now. Sometimes it's harder, sometimes it's easier. Now we are soldering, and as soon as it moves, we are ready. It is hovering, we are ready. We're reflowing, we are poking. And now we are aligning everything we have poked. We are reflowing and reflowing in order to be satisfied that the IC is in place and with good attach on the PCB. Now we're cleaning with the isopropylic and our toothbrush. I think that we are okay with the soldering. And it is time to check if we are having any shorts. We are not having any shorts. So it's time to test the power reception. If we are having anything good, or we are having still 5 volts. So let's go on the overhead. We have plugged the charger. We're receiving the 20 volts, but the consumption is not proper. We are not booting. So we'll put the motherboard on its plastic plate in order to be protected from maybe copper threads that below. And we will check the voltage that it is hovering, but I think my charger is not very good. I will plug it the right way and it will be okay. Yes, we are having the 20 volts. So let's go and check for voltages. We are receiving the 1216, 60, I'm sorry. Now it's a bit, no, it's okay, it's okay. The PP bus G3 hot is feeding the motherboard. Let's check for other voltages. Let's check for the 5 volts, which are present. Let's check for the 3 volts. We are in the other side of the coil. This multimeter is measuring the pulses, but on this pad of the coil, it will show the 3.3 volts as it should. So we're having the 3 volts, but we're missing something. Something which is let's go and see if we're having any voltage on the we are having voltages, the right voltage on the power management IC, which is feeding the T2 chip. So we're missing something. Which could be the NAND. Let's go and check. The NAND is receiving 2.5 volts. The 0.9, the 1.8, we're okay. The NAND on the left side of the board is okay. The 3 volts are coming, the PP battery 3 hot is coming, the 5 volts are there, the PMIC is working. We have 1.8 volts, 0.9 volts, but we're not receiving the 2.5 volts on the other side of the board for the NAND. So we must solve this and then check why it's not booting. So let's go and see under the microscope. This is the capacitor that it should have 2.5 volts. The PP bus is there, but 2.5 volts is not there, so we will try and check if we are lucky enough to have a shorted capacitor, which is not the case. And after that, we will go and check the circuit that is generating this 2.5 volts for the NAND, which is this circuit. You can see that it is corroded from water damage. So let's go and see for shorts. I will apply some more light to see better. We're not having any short there, neither. We're not having any short there. No value there. Maybe I'm not pressing hard. Now I'm pressing. It's not sorted. So they are ugly, but they're not sorted, so they will stay on our circuit for the moment. Let's go and power the notebook and check for voltages, which nothing is present. Let's go and see if we're having the PP bus. The PP bus is there, so we are having input but not output. The enable is present, I think, because the other NAND regulator is working. So I will assume that this regulator is broken or shorted or has water damage beneath or debris from the water and is not functioning properly. The regulator will be removed. We will add flags, as you can see, and with our hot air and our tweezer, this regulator will be removed. This is the chip. It's corroded. You can see that it's corroded beneath. We will clean up the pads. I think we must reball this chip, clean it up and reball it. And who knows, it will work. That's the first we must do. So let's go and reball this chip. We will add some flags. We will wipe the old solder, but we will not scrape because we may damage the mask on the chip. We're trying to remove any dirt from the IC without scraping the mask. I'm saying all over the same things because you may harm the chip. So we will find something that fits and try to reball the regulator. Okay, that's good. Now you can see better. We will add some soldering paste. And after that, we will wipe the excess and heat up. We will remove the IC, and hopefully we will have no balls on the stencil. We are good. Yes, it is good. And now it's the time to put it back on its place. We will clean up the pads. I'm trying to find a small wick, but this is not the case. I will cut a wider one because I cannot find the proper one. Maybe I'll damage something around with a curly thing that I have done, but it's not the case. We are good. We're aligning the chip. That is on our tweezer. Add some flux, always help. We will press it down, the flux will do the rest. We're aligning, and with low air and high temperature, we will try to solder this regulator back. You saw that almost lose it. Lower speed or lower airspeed for having the ICs on the motherboard and not on the floor. And as we are heating up, the solder will melt, the balls will melt and solder on the PCB. We're cleaning up a bit. We're checking for shorts. We are not having any shorts. We are good, and now we will test. If we're having this voltage as we should, and we are having 2.5 volts, and we are very happy about that. So we'll go on the overhead and check if the MacBook is booting, if he's consuming the right amount of amps. $20 volts, but not a good consumption. And now we are assuming we are having the 2.5 volts, as you can see. We are having the 3, the 5, and the PMIC is working fine. It's generating all the voltages that the T2 chip is will need. So we are assuming that maybe, or if we're lucky, the MacBook board is in DFU mode for a reason. I don't know the reason. And we will try to connect it. You can see when I am measuring the voltages that they are all present. And now we must connect to another MacBook in the configurator to check if the MacBook is in DFU and try to restore it. I was right. The MacBook is recognized from the other MacBook from the the MacBook configurator, and is trying to reprogram the BridgeOS on it, but it's not the case. The 2141 needs a battery connected, so we will do the job elsewhere. We have already restored. You can see this is the right MacBook. So the MacBook was restored by the other MacBook, and now we are applying what we must do in order for the macOS to work properly. That was the case. You can see that I'm working on it. That was the case. We have completed the repair of the voltages, but the MacBook was in DFU mode. In other situations, someone could stop and not checking for the DFU. If the voltages are there and the PMIC is working and generating the voltages for the T2 chip, we must check for the DFU, and that's the case here. So, that was it. That was the repair as you saw. If you liked this video, consider like, subscribe and share. Thanks for watching. See you in another repair. Bye.